Assalamu alaikum. How are you? Hope everyone are safe at home. Okay? May Allah bless you. Ramadan Kareem in advance. Ramadan is very nearby, isn't it? So all of you pray well and pray for each other for the safety of our world. Okay? So we can hope that inshallah everything will be fine and okay very soon. Okay? So let's start our topic: elements, compounds and mixtures. The detailed study we have finished in our classes during the regular classes. We just brush up our knowledge, okay, brush up our memory. Assalamu alaikum, how are you? Hope all of you are safe and staying home. Okay, it's for our protection. Okay, may Allah bless you to get uh, over all this condition very soon. Ramadan Kareem in advance. Ramadan is coming, so all of you pray well for yourself as well as for the whole world. Okay, may Allah bless you and your family. So let us begin our topic: elements, compounds and mixtures. These we have learned in very detail in the classes during our regular classes, but I am just brushing up your knowledge. What are elements, compounds, mixtures? Important points are discussing here, okay, in this chapter. The most important thing is why chemical symbols we use or scientists use, because in this class 8a, 8b, 8d, 8e, each child has different name. Why? We can just say girls or boys, but if I want to talk a particular boy or girl, if there is no name, it is difficult to understand, isn't it? So like that, the elements are arranged abundant in the world. 118 elements now found by different scientists. They gave the names for each element, but it is difficult for to write the whole name of the element. Okay, so they use some symbols to represent the elements. 1813, Jones Jacob Berzelius is the first scientist who represent the elements as a symbols. Still we use that method to represent the elements. Okay, each element identified by the first letter of its name. Example, hydrogen. If the same names are there, what we write? The second letter we are using. some of the elements we are using their old names, like iron is using as the symbol Fe because its old name is ferrum, so Ferrum. Like that, many examples we have learned that time. So you just go through these slides and you will understand what are the example for each. Kalium is a Latin word for potassium, also like natrium for sodium, Na, because the English letter is not matching with the symbols in the periodic table. You can see that. Don't worry about that because there are some rules to follow how to make a symbol. Maybe after some places, maybe after some scientist like Einstein. Einsteinum is a element and Uranus is a planet, okay, but uranium is an element, like that. In order to honor some places or properties of something, like chlorine is a green thing, so it is a word, Latin word chlorine, so we are using Cl for the representation of that element. So the symbols came as different basis, okay, maybe the first letter or maybe first and second letter, maybe the place name, scientist name or planet name, like that, etc. Okay, hope you understood. Here you have to know about only one thing. You have to be very careful that when you are writing the symbols, the thing is that the capital letter and small letter, you have to be very careful. The first letter always will be capital and the second letter will be the small letter. And if there is number under the name, you have to subscript, underscript, okay? You can see the periodic table. We have learned about this very detailed study of periodic table in another chapter, okay. All of you have learned that, I hope, like that, okay. So the first one, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Say with me that song. We have practiced the song, isn't it? So that you do it now, and 20 elements you have to study in the order of their atomic number. Don't forget, okay. Daily you say, then it will be a habit, or you will never forget, like multiplication table. From grade 3 you are studying multiplication table. Still, from any moment if they ask, you will understand, like that. These 20 elements you will never forget in your life if you make it as a habit to just one time you remember this every day before going to bed, and after waking up from the bed you just make a small paper in front of your cupboard, okay. So read only one day, one time, 20 elements, inshallah you will get full, okay. 20 elements you have to remember in the order, that's very important. So, what are atoms? What are elements, compounds, molecules? All we have learned. Atoms, a, a full lesson we have learned what are atoms. Okay, atoms are the basic unit of every matter in this world, and it has proton, neutron, electrons. All of you know about this one, isn't it? Atomic structure we took as the complete lesson. Okay, and it has charges and all. So, elements are what? Elements are made up of atoms. Maybe this atom, the same kind of atoms joined together to make one element. So each element are unique and they are showing different properties than the other, because one element is consist of one kind of atom, the another element is consist of another kind of atom. Can you say one example for element? Can you say? Can I call anyone's name now? Okay, so the element is one example hydrogen, then calcium, potassium, all are elements. Okay, so molecule is a substance that contain two or more atoms chemically bond, and compounds are actually different kind of elements are joined together, like hydrogen combined with oxygen to make the water. Okay, so they are showing different properties of different elements combined together to make a completely new thing there, because hydrogen is a gas, oxygen is also a gas, but when they combine make a water is a liquid, isn't it? So the compound is completely different from the combination of two elements characters. Okay, and these are the main points about these atoms, elements, compounds and molecules. All molecules are what? All in this part name a compound, we took in very 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 detail minute details we discussed in the class. So all the points you just go through. The first part of the name will be the first name of the element, second part will be the second part, and if both are together we are using the suffix "ide" when it is connected with a there is, if there is no other element, they are arranged as a ide, ide, sodium chloride. I think all of you remember all this. You just go through your notebook, you can recollect the points. And if there is oxygen are attached with any other element, or any element, if it is repeating we are using the prefix di or tri. So carbon dioxide is a very good example. And if there are two elements are joined together, the first named element made up of two names, that means sodium, oxygen and hydrogen, if they are combined together we are using as a combination of oxygen and hydrogen, so we will get hydroxide. The sodium will be the same sodium first name, but oxygen and hydrogen we are taking as a combination name hydroxide. Okay, and the suffix ate we are using, that means if there is three elements or more elements, but the more oxygen are attached with the second element, so we are using the word ATE, 8. So calcium, carbon and oxygen, three oxygen are joined together, we are calling it as calcium carbonate. So all these 6 points you just go through again and again and you do some example, inshallah you will get the correct answers. Okay, you just go through our notebook and worksheets I gave, and also I uploaded some worksheet in the Moodle, so please practice again and again, you will get it very clearly. Okay, hope you have got a very good idea about this one. From this you can see the mixture. Mixture is a combination of two or more separate substance. From this picture you can see the green bowl, yellow bowl, small, big. Okay, they are combined together, but they can be separated. Okay, so that's why we are calling as a mixture. So iron or sulfur may be mixed together, but we can separate them. They are not chemically bonded. So iron sulfide formed, we can separate them, mixtures. That is a specialty of mixtures. Here you can see a table with different kinds of mixture. Solid can be mixed with a solid, example sand. Solid mixed with a liquid, you can see an example of clay and water. It forms a solution, isn't it? And solid mixed with a gas, that is smoke. Liquid mixed with a liquid, that is emulsion. Paint, milk is a very good example for emulsion. Okay, the fat droplets mixed with water, that is the milk. Okay, liquid with liquid, example. Gas mixed with gas, so other example nitrogen, oxygen, it's a mixture of gases in the atmosphere, isn't it? And liquid mixed with a gas, aerosol, the perfumes. Okay, and the gas mixed with a liquid, that is foam. that shaving cream and all will make the foam, right? So that is gas mixed with liquid. These are the some example for different types of mixtures. You have to learn one example from each category. Maybe you are thinking why this teacher is very fast and saying, because all these we have explained in the class with a very good explanation. Okay, that's why I'm just brushing up your knowledge and I'm not boring you. Okay, so yeah, I'm just giving you the idea about the old chapters which we learn in the regular class. So different words we are using to represent the different solution: miscible, immiscible. Sometimes the mixtures are forming liquid with liquid, isn't it? So if one liquid is completely dissolved with another liquid, we are calling as a miscible. That means if you take one glass of milk and water, if you mix it completely mix, isn't it? That is called miscible solvent. And immiscible means sometimes it is not mixed together. One oil and when you take the water, it cannot be mixed. That is called immiscible. But the soluble means if gas or solid mixed with a liquid, what will happen? It completely mixed. That is called soluble. And if a solid or gas mixed with a solvent like water, what will happen? If it is not mixed, it is known as insoluble. So these are the soluble and insoluble equal to miscible and immiscible. But in miscible and immiscible, we are talking about the liquid with liquid solvents. But in solubility and insolubility, we are talking about gas or solid solute with liquid solvent. That is the only difference. This terminology also we explain in the class. Now the next part is separating the mixture, separating an insoluble solid or liquid mixture. Okay, so I just take a one glass of water with sand. So it is a large particle sand. So it is very easy for me to separate. Just keep for some time, the waste will sediment down, and what will happen, I can pour out the rest solution. That rest solution we are calling another name, filtrate, that we explained. All this I showed in the lab. You remember that one, the last time we took to the lab and show this decantation or decanting. That means the sedimented part left over the jug and the water we can pour out, that is known as decanting. It is for large particle separation. If it is small particle, what will happen? Like tea leaves, I put it in a tea. So what I will do? I will do the sieving, isn't it? It's a kind of filtration. This also I showed in the labs. You check the picture, you will get the funnel, filter paper, the residue which we get on the filter paper. We are calling it as residue, and the solution after pouring this solution from the filtrate removed out, that is called as filtrate. And centrifuge means another kind of high revolution speed it will move, like our washing machine, it spins very fast and the particle will sediment down, and we will get the filtrate as the clear solution in the test tubes. This all we shown in the lab, so I'm just brushing up. Maybe you will get bored if I explain more. Okay. Now separating a solute from a solute or solvent mixture. Okay, so from the in this category we are using two types of separation method: evaporation and crystallization. This also I showed in the lab. Copper sulfate solution, you remember the blue color, and when we keep it on a fire, the water evaporated out and we got the crystallization. The salt water from the sea, we are doing this evaporation method to crystallize the salt, table salt, mal, isn't it? So that we get by the procedure crystallization and evaporation. And separating several different solutes from a solvent is done by a chromatography. This also I showed in the lab as a chromatographic. After separation the pigments, what we will get, That paper we are calling as chromatogram, isn't it? And that solution is a acetone. That is the solution we are calling. You remember? Here, some uses of chromatography I have mentioned. We can separate the colored pigments like a chloroplast in the plant leaves. We are using this by chromatography, and some kind of adulterate in the food also we are just removing through the chromatography. And many food industries, medicine are using this chromatography. The another kind of separation is separating a solvent from a solute or solvent mixture. This is also a mixture of we are using the seawater after the cleaning, isn't it? That is done by this distillation method, simple distillation. The picture is very clear. From that you will get the idea. And separating two immiscible liquid, that means one liquid with another liquid is not dissolving, just we explained before, isn't it? So vinegar and oil, if they are joined together, it will not mix completely. That is known as immiscible liquid. So it will keep for some time, for a long time. After that you can see the vinegar will go down and the oil will come up. That is another kind of separating, just keeping them without disturbance. So, Alhamdulillah, we have finished all our chapters in second semester. Alhamdulillah. Please keep on watching the same video, repeat, repeat, repeat. Only then you will get the clear idea, because we are not seeing each other. So, so maybe you have some doubts. So, if you continuously watching, you will get the main points, and from that you can get the clear idea. On this occasion, we would like to say a great thanks to Mr. Yunus and his family, to pray for his family. I'm sorry, pray for his family, because in this crisis he gave a wonderful opportunity to keep in touch with my beloved children, and we didn't miss any topic during the second semester because of this crisis. So may Allah bless him and his family. And see, my dear children, you have to write all the notes what we have go through this video, and write down this recap questions, and you solve yourself and correct yourself. We are sending the updated homework and homework to the homework groups, and the extra questions to the Moodle also we are uploading. Okay, so we always keep updating, but you have to also update it. Don't lose the link between our education and everything. Hopefully, inshallah, everything will be fine. Pray for that one. Okay, only Allah can help us. We experienced that. Before we were saying only Allah can only do, Allah can only do, but now we experienced what it is, isn't it? Even if the health or wealth or anything is there, if something happened throughout the whole world, what we can do? Nothing. We are nothing in front of Allah's power. Okay, so pray well, pray for each other. And Ramadan Kareem, it is very nearby. So we have to pray very, very, very well for Allah, and Allah will bless us. Definitely, we have to trust in Allah and strongly believe in Allah. Allah will help us to overcome all this problem. Okay, may Allah bless you, and again, stay home, stay safe, stay blessed. Masalama. Take care. Inshallah, until a notice come from everywhere, we can contact through this electronic media, isn't it? Okay. So may Allah bless you. Take care. Bye. Masalama.